Who are we? Where do we come from? And where are we going? How and why was the universe born? These are some of the eternal questions associated with astronomy that continue to pique human imagination from ancient times to the present day. Astronomy is the science that has as its main purpose the determination of the positions, dimensions, and movements of the celestial bodies. So in this video, we are going to talk about something magnificent that will help us understand the humanity's perception over the years about astronomy. Let's analyze and get deep into the history of astronomy. Astronomy is the oldest of the natural sciences and powerfully associated with religious, cosmological, and astrological beliefs. The first astronomers were the ones who could distinguish the planets and the stars due to the fact that they were the first ones that made observations and predictions. Before we continue with our exploration to the history of astronomy, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel so that you don't miss any of our weekly videos. From the beginning, humanity turned its eyes to the sky full of awe and questions. The sunrise and sunset of the sun, the phases of the moon, the alternation of seasons, the movement of other planets in the sky, the appearance of comets, and the shocking phenomenon of eclipses were the first evidence that there is something above that needs to be discovered. That is how astronomy started to develop. These incidents raised our curiosity and made us wonder, what are they? Where do they come from? We do know today, but imagine in those days. They were like gods. As early as the 6th century BCE, ancient Greek philosophers documented evidence that Earth was a sphere. They noted that the night sky looked different when seen from various locations on Earth, hinting at our planet's curved surface. They also observed the round shadow of Earth on the moon during lunar eclipses. These philosophers were even able to calculate the circumference of Earth quite accurately. They did this by measuring the length of the shadow cast by an object at exactly the same time in two different locations. Taking into account the distance between those two locations and the difference in the length of the shadows, they calculated that Earth's circumference was about 46,250 kilometers. That is very close to the real value of 40,075 kilometers. In the year 185, Chinese astronomers became the first to document a supernova. Several supernova explosions have been observed since then, including a particularly bright one in the year 1054, which at its peak was 4 times brighter than the planet Venus, one of the brightest objects in the night sky. Some supernova are even bright enough to be visible during the day. The notion that our own galaxy, the Milky Way, is but one of trillions of other galaxies in the universe only dates back about a century. Before then, nearby galaxies were thought to be cloudy regions of the Milky Way. The first documented observation of the neighboring Andromeda galaxy was in the year 964 by a Persian astronomer who described it as a nebulous smear. For centuries, it was simply known in star charts as the Little Cloud. Before the 16th century, Earth was commonly thought to be at the center of the solar system, with all other celestial objects revolving around it. This is known as the geocentric model. This theory, however, did not match some confusing observations made by astronomers, such as the path of planets that appear to move backwards on their orbits. In 1543, Polish astronomer Nicholas Copernicus proposed a heliocentric model of the solar system in which the planets orbit the Sun. This model explained the unusual path of planets that astronomers had observed. The new theory was one of many revolutionary ideas about astronomy that emerged during the Renaissance period. The work of astronomers Tycho Brahe and Johannes Kepler led to an accurate description of planetary motions and laid the foundation for Isaac Newton's theory of gravitation. This process dramatically improved humanity's understanding of the universe. Their observations and investigations were strengthened by the invention of the telescope in the early 17th century. Italian astronomer Galileo Galilei popularized the use of telescopes to study and discover celestial objects, including Jupiter's 4 biggest moons. In his honor, they are known as the Galilean moons. Throughout the years, we have found ancient monuments of astronomical interest that are about 5,000 years old. For instance, the pyramids of Egypt and the megalithic Stonehenge monument in England have an astronomical orientation so that they are connected to various astronomical phenomenon. The orientation of the pyramids shows, for example, that the Egyptians knew some basic addresses in space used by astronomers. It's also known that they've been using a calendar since 4000 BC. So this means that they were well aware of the phases of the moon and the movement of the sun in the ecliptic. A significant factor to our knowledge of the universe plays the Greek astronomy. The breakthrough that gave Greek astronomy its own particular character was the application of geometry to cosmic problems. The oldest extant source that clearly states that Earth is a sphere and that gives a sound argument to support the claim is Aristotle's On the Heavens. Aristotle mentioned that Earth's shadow as seen on the moon during a lunar eclipse is circular. He also mentioned the changes that occur in the stars that are visible as one moves from north to south on Earth. Aristotle claimed that certain mathematicians had contrived to measure Earth's circumference and had found a value of 400,000 stads. Also in the 3rd century BCE, Aristarchus of Samos applied geometrical reasoning to estimate the distances of the sun and the moon on the sizes and distances of the sun and the moon. However, his initial premise included several questionable numerical values. For example, he assumed that at the movement of the quarter moon, the angle between the sun and the moon as observed from Earth is 87 degrees. From this, it followed that the sun's distance is about 19 times the moon's distance from us. The actual ratio is about 389. A second doubtful observation was that the angular size of the sun or the moon is 2 degrees. Another of Hipparchus's contributions was the discovery of precession, the slow eastward motion of the stars around the zodiac caused by wobbling, over a period of 25,772 years, in the orientation of Earth's axis of rotation. Hipparchus's writings on this subject have not survived, but his ideas can be reconstructed from summaries given by Ptolemy. Hipparchus used observations of several fixed stars, taken with respect to the eclipsed moon, which had been made by some of his predecessors. On comparing these with eclipse observations he had made himself, he deduced that the fixed stars move eastward not less than 1 degree in 100 years. The Babylonians, in their theories, revised their locations of the equinoxes and solstices. For example, in one version of the Babylonian theory, the spring equinox is said to occur at the 10th degree of Aries. In another version, at the 8th degree. Some historians have maintained that this reflects a Babylonian awareness of precession, on which Hipparchus might have drawn. Other historians have argued that the evidence is not clear, and that these differing norms for the equinox may represent nothing more than alternative conventions. It is important to mention Galileo, a famous scientist that contributed to the knowledge we have today of our universe. He is well known for his telescope. Galileo, through his telescope, that is the first of all humans, in 1609, observed the mountains and valleys of the moon, the stellar nature of our galaxy, the sunspots, the planet Saturn with its ring, but mainly the phases of Venus and the 4 satellites of Jupiter. His unique observations radically changed the worldview of his time. A heliocentric follower of Nicholas Copernicus, he realized that on the one hand, the phases of Venus would show that this planet orbits the Sun, and on the other, the 4 satellites of Jupiter, which has since been called Galilean, provided the solution. The Moon was not the only case. There were other celestial bodies orbiting a planet. Their existence forever destroyed the belief that all celestial bodies revolved around the Earth. Our little planet, with all that entailed, has ceased to be the center of the universe. Combining mathematics with physics, Galileo rejected the existence of the perishable sublunary and the indestructible crystalline supermoon world, proving that the same laws govern and apply throughout the universe, thus expanding the limits of what we can see. In the same year, 1609, the genius astronomer Johannes Kepler, the legislator of our solar system, published a book in Heidelberg called Astronomia Nova, and indeed it was news, as it recorded the first 2 laws of the motion of the planets and discovered the first of all the astronomers of all time, the elliptical orbits of Mars and the other planets around the Sun. Influenced by Copernicus and his teacher Michael Maestlin, a heliocentric, He relied on the accurate, long-term, and credible observations of the great Danish astronomer Tycho Brahe and gave the laws that have ruled the planet since then. It was amazing that this mystical and religious man overcame his fears and hesitations and uprooted the Earth from its central position and the planets from their circular orbits. The first law says that the planets race around the Sun's elliptical orbits of which the Sun holds, while its second law shows us that in equal times they are erased from the planet equal areas. That is, the Sun remains still and occupies one outbreak of ellipse, while the planet, when it moves along its elliptical orbit, scans at equal intervals, equal areas, inside the ellipse, and not equal arcs on its perimeter. Unprecedented discoveries that laid the foundation of modern astronomy and made Kepler a legislator of the solar system. As you can see, this was just the beginning. Thanks to the construction of perfect telescopes, astronomers have slowly managed to reconstruct the history of the universe. What is certain is that astronomy's progress over the last 400 years has provided answers to questions from millennia, putting an end to all sorts of superstitions. A huge contribution to the building of human civilization. Eclipses are no longer but mere alignments and additions of celestial bodies and comets. These mysterious visitors from the depths of the vast universe are unburned celestial bodies, some dirty snowballs, as the famous astrophysicist Fred Whipple describes them as early as 1950. Babylonian astronomers in the 1st and 2nd millennia BCE tracked 5 points of light in the night sky that moved differently than the other stars did. They concluded that something fundamentally different existed. These 5 points of light were not stars at all. Historians and astronomers now believe the Babylonians were among the first to recognize the planets Mercury, Venus, Mars, Jupiter, and Saturn, which become visible to the naked eye at different times of the year. Today, astronomers collect data about celestial objects by using huge telescopes on the ground as well as in space. For example, in 1923, Edwin Hubble fundamentally changed the scientific view of the universe when he used the 2.5-meter diameter Hooker telescope to prove that the Andromeda Nebula exists beyond our Milky Way galaxy. Hubble's discovery of the universe's ongoing expansion also paved the way for other astronomers to theorize its origin. The Big Bang Theory, first proposed by Georges Lemaitre, was later bolstered by strong evidence. The discovery of the cosmic microwave background, CMB, faint noise left over from the massive explosion that gave rise to everything in the universe. The CMB was accidentally discovered by radio astronomers just 5 years before the 1969 Apollo 11 moon landing. These modern telescopes, equipped with massive mirrors, allow astronomers to capture the light of very faint and faraway objects. Specialized techniques and sensitive scientific instruments have been developed to study not only visible light, but also the entire electromagnetic spectrum of light, including infrared light, radio waves, and X-rays. Large complex telescopes and advanced techniques have even enabled astronomers to directly observe phenomena including black holes, distant exoplanets, and gravitational waves. Improvements in satellite launch and design allowed astronomers to collect even more data about planets within our solar system in the second half of the 20th century. Several robotic space probe campaigns, including Mariner, Venera, and Voyager, ventured farther than ever before. Thanks for watching, everyone. I would really like to know your opinion regarding the history of astronomy. Do you think that from the very first start of our presence on Earth, we want to explore the universe? Do you believe that if it wasn't for these observers, we wouldn't be able to have the knowledge that we have today? Let me know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.